All right, so previous recording did not have any volume on it, so I'm going to try this again. Let's see if I've got a mouse. There's my mouse. Testing all of my various features out here before we start. Okay, got it going. All right, so today the goal is to discuss density, so we're going to get going here. Density is found in the textbook, but I think that this should be pretty understandable. All right, so the basic concept of density is that it's the amount of matter present in a given volume of substance. I don't think that's necessarily something you need to write down. It's a little bit wordy. Basically, it's how much mass there is per unit of volume of stuff. If you're taking a look at those two images on the bottom of the screen here, you can see that they both have the same volume, but that they have different amounts of mass. This means that one of them is more dense than the other. And it is the left-hand one that's more dense because it has more mass per unit volume. If I'm going to do a calculation of density, it's always calculated the same way. Density is mass divided by volume. Because mass units are usually grams and volume units are usually milliliters or cubic centimeters, it turns out that the units of density always wind up being grams per milliliter or grams per cubic centimeter. I'm going to cross out this grams per liter. We do see grams per liter and kilograms per liter, but not often in a class like this one. Okay, that was the mathematical concept of density. Here are some actual concepts of density. So if you're taking a look, you can see that density controls how substances behave in each other. I'm going to start out by talking about the hot air balloon real quick. In a hot air balloon, the whole reason why a hot air balloon floats is because the density of the balloon is less than the density of the air around it. The reason for that is if you think about the kinetic molecular theory, if you think about the tiny little molecules of air, every time you heat them up using those burners in that balloon, the molecules start moving faster. They get farther apart from each other, and because they're farther apart from each other, they're less dense. It's a heck of a lot like this. Cold, trying to find my mouse. There it is. So cold air molecules are closely packed. Hot, if I could write hot air molecules are less densely packed. Because they're less densely packed, they float on top of the colder air. Thus, hot air balloons go up. Okay. Another concept here is right here. You can see that different substances will float on top of each other based on their densities. Honey and water are pretty easy ones to get to float on each other at home. You can see based on this we've got 3 different densities of 3 different objects, and they float differently in the water. Something of an extreme low density like this, here, the one thing we should know, I should have written this down. The density of water is 1.00 grams per milliliter. So something with a density of 0.1 is going to have 90% of it not underwater. 10% will be underwater. Something that has a density of 0.5, such as this one here, is going to have half of it above and half of it below water. Something with a density of 0.9 is going to have 10% of the object above water and 90% below. Okay. The Earth is made up of various layers. I'm not an earth science teacher, but I do know that the inner core of the Earth is very, very dense, and that the layers above it are less dense. Eggs, you can tell if they actually go bad by checking out their density. if you put them into water, the interesting thing about eggs is that as they age, they dehydrate. Water can dehydrate through the shell, and an air bubble is formed inside. So if an egg gets a big enough air bubble that it floats, it's too old to be eaten. Okay. Again, here we go. Water has a density of 1.00 grams per cubic centimeter. Steel has a density of 7.6. Why do boats float, such as this giant cargo vessel that's obviously extremely heavy? It actually doesn't have anything to do about the heaviness or the lightness of objects. It has to do with the density of it. A boat is shaped like this in profile. All of this is air, and air has a very low density. Matter of fact, the air's density is written right there, 0.179 grams per mil. Most of this boat is made of air. The air pockets in the boat make it less dense and allow it to float. Okay. It also allows us to know that helium gas, because helium balloons float, it allows us to know that helium gas is less dense than air. If we're solving problems, I'd like you to use what's called the guess method. The guess method is the G, the U, the E, the S, and the S stand for given, unknown, equation, substitute, and solve. So I'm not asking you to guess the answer. I'm asking you to show a logical step of processes that helps you to find the answer. So, for instance, G is standing for given. So I would write down volume equals 23.53 milliliters, because that's the first thing that's given in this problem. The student finds 23.53 milliliters of a certain liquid weighs 35.062 grams. So mass equals 35.062 grams. The density of the liquid is being asked for. Okay, so there's my G right here. My unknown is my density. An equation that I can use to solve this is density equals mass over volume. I can then do what's called substitute. That's my first of my S's. So substitute in density equals, I've got to substitute right, mass is 35.062 grams. Volume is 23.53 milliliters. So the density winds up needing to be calculated. The units don't cancel, and we'll talk about the units in just a second. Let me get the calculator out here. That's not the calculator. Where's the calculator? Here it is. So we're going to take 35.062 and we're going to divide that by 23.53. We hit equals, and we're getting 1.49009. Okay, we want to round to sig figs. It looks like I've got 4 sig figs and 5 sig figs, so 4 is the lesser number. So I'm going to write down an answer of density equals 1.490 grams per milliliter. Okay, this is pretty dense stuff. If I'm going to look at that number, it's more dense than water. So that means that I should be able to pour water on top of this and have water float on it. All right, I think that's it. So I'm just going to hit stop.